Hello everyone, so I'm back again with one of the linked list algorithms. So today what we are going to discuss, that is linked list traversal algorithm. So traversal we required in many linked list operation, like suppose we want to do insertion or deletion from the end, or insertion at the beginning or at the end, or a specific position, right? Those kind of operation, and that we required traversal. Even in searching algorithm, also we required traversal. So anyhow, suppose we want to traverse, we want to access each and every node of linked list, right? So I require traversal. Let me give you one example. That suppose I have 4 nodes, and this is the last node, so it is null. This first node, that is head, this represent that link. The link part stores the address of this node, this link part stores the address of this node, right? So let us say these are node A, B, C, D, and I want to access all those, right? Suppose here we have some data 3, 2, 5, 7, anything, right? So I want to access all the nodes. I want to do some processing on each of the nodes, right? So for that I need to first visit this node, then I need to go for this node, then I need to go for this node, and then this one, right? So it's called traversing, right? So first you should understand that what is traversing, right? So it's a travel from the first node to last node. We need to traverse each and every node, and any operation that we want to perform on that particular data, that can be performed, right? So for traverser, first the step one is we required one pointer, right? So let us say we have a current pointer, right? So like that is initialize pointer. That is my very first step, right? So initialize pointer, and that I'm taking one pointer called current pointer, right? And I'm initializing it with the value of head. As you are aware of, head is the pointer that stores the address of the first node, right? And we need to traverse, right? We want to traverse. So we want to traverse from the first node, and then we need to move to the second, to the third, fourth, and the last node, right? So first we need to initialize my current pointer with head. So this pointer also starts with the first node, right? Now the step 2, that I need to have a loop, because I need to go from the here to B, A to B, then B to C, and then C to D, right? And then after D we don't have anything, there is no node, right? So we should have some constraint that will stop this loop, because ultimately this is looping structure, right? So for terminating that looping structure, otherwise if we don't have anything, right, then what will happen, it will go into the infinite loop, right? So we want to break that, so we have some condition, right? So here we are taking that while condition, that while. Now here, as you can see, that this is my last node, and how can I get that it's my last node? That is, the link part is null, right? The link part of the current link part of that particular node is null. That only indicates that it's the last node and no need to go further, right? So here we are having that terminating condition, that link part of the current pointer, that means current pointers link, right? If this is equal to null, then we need to terminate. So here we are having the condition that if it is not equal to null, so then it will go for this block, right? While block, understanding? So this is like condition that current pointer's link is not equal to null. That means it is not my last node. And if it is not my last node, then I can go ahead there of whatever the next step we are having, right? So then step 3, that is process info of current pointer, right? Now here whatever process you want to do, right? Suppose let us say I want to print, right? I want to print the information part, so you can simply like print info of current pointer, right? Now after this what I need to do is that I need to move, this is for the first one, right? I need to move from first to second, A to B, right? As of now you can understand like this current pointer is initialized with head, that means it is having the address of A, right? So now as of now my current pointer is pointing over here, right? Now what I did, that current pointer's link is not equal to null. It's checking. Now let us check the current pointer's link. Is it null? No, it's not null. It is having the address of B, right? So it will go into this step 3 and then it will process the info of current pointer. Let us say here we are printing, right? So what is info of current pointer? That is 3. So it is printing 3, right? Now next what I need to do, I need to shift my current pointer because this task is done for this A. So now I need to swap, actually not swap, we need to jump from this position to this, right? A to B, right? So I need to move my current pointer. So how can we move my current pointer? So right now current pointer is having the address of A, right? And I want current pointer the address of B. Now address of B is available where? So that is in the link part of A, right? So what I am doing, that my step 4, that would be simple move the current pointer. So I am just moving my pointer to next node, right? So for that I need to just use this link, right? So link part of current pointer, right? Because current pointer is also pointing to that only, na? Right now current pointer is pointing to A only. So link part of current pointer, that is what? Address of B. And that I need to go with, that I need to give it to current pointer itself, right? So is equal to, that is current point, I am assigning the value to current pointer, right? So this current pointer is equal to link of current pointer. So as you can see that here this current pointer is holding the value of A, that is address of A, that address of A node, right? Now link of current pointer, that means this part, this is info of current pointer, this 3 is info of current pointer, this link part is link of current pointer, right? So link of current pointer is holding the address of B. Let us say this B is having address 1011. So here this is holding the value 1011, and if I go this link of current pointer, right? So that is equal to 1011, and I am assigning that 1011 to my current pointer. So my current pointer will jump from here to here. Now my current pointer is pointing to B, right? Again this is a while loop, so again it will go to step 2, right? It will check that current pointer's link, is it null? No, it's not null, right? It is holding the value of C, right? address of C. Value, that means address of C, right? Then it will process the info part. So what we have, print info of current pointer. So as of now my current pointer is this, its info part is 2, so it will print 2, right? Then again it will simply like current pointer is equal to link of current pointer, that means it is making a jump or a hop, you can say. So now this current pointer will jump from here to here. Now this is my current pointer, right? Again it will check that current pointer's link, is it equal to null? No, it's not null, right? So it will process, so print info of current pointer. So what is info of current pointer? That is 5, right? Now it will check, now it will again hop that current pointer is equal to link of current pointer, right? So link of current pointer, that means it will jump it over here, right? And then if we have that while current pointer's link is not equal to null, but here it is null, right? So here it will come out of this while loop, right? And it will be terminated over here. You can process anything, right? Here a printing purpose. So as of now you can say 3 to 5 is printed. You might be thinking that what about 7 is yet not printed, but current pointer is holding that value, so you can simply print wherever you want. You can simply print info of current pointer and that will print you 7, right? And so this is it. And the last step, step 5, that is exit or return, right? So this is a very basic traversal algorithm. I hope you understand it, right? Because this is like a very small algorithm, but it is required in many algorithms. If you go for the insertion at the end, right? So for inserting the node at the end, you need to traverse up to the end, right? If you want to delete from a specific position, so you need to traverse up to a specific position, then and only then you will be able to delete it, right? So for that you required this linked list traverser. So I hope you understood the concept, because concept is important. See, this algorithm, you can write, algorithm is a human understandable form, right? So if there is no fixed format of algorithm, you can write it your own, right? But when if you have that concept, if you have your concept clear, then you can write it. If not, then it is very important to first of all clear your concept about any funda, right? So for that, suppose this is your topic linked list, right? So you should have a clear idea about what is linked list, how to create it, how to traverse it, and how to do insertion and deletion, right? So that's it for this lecture. Thank you very much.